Good day, my name is Ikmal Fahmi bin Yusoff. I'm from Group 5. Today, me and my group mates are going to try and teach you about computer-related maths and statistics chapter 5, Trigonometry. This is a triangle. I'm sure you've seen it before. 3 sides, sum of internal angles is 180, Illuminati, pretty normal stuff. This chapter is actually about its cooler cousin, the right angle triangle. You can tell that it's right angled because of the tiny box in one of its corners. This is a 90-degree angle. All right angle triangles have these. Remember that. Now let me introduce you to the sides of this triangle. Let's start with the simplest. Opposite to the pointy point of the 90-degree box is the hypotenuse, the longest side of a right angle triangle. Its position is always constant. It's always opposite to the 90-degree angle, and it's always the longest side. As for the other 2 sides, let me introduce you to this pill-looking thing. This is theta, a cute angle. Theta can pretty much only be in these 2 positions, as if it sits here, it'll be taking the 90-degree angle spot, and that would be very rude. Anyway, the last 2 sides depend on where theta is positioned. They're pretty much interchangeable. Adjacent is the side between theta and the 90-degree box. Meanwhile, the opposite is the side opposite to theta. Makes sense, right? Alright, after you get used to identifying these parts, you're ready to start finding the parts. You see, most questions in this chapter boil down to, here's 2 to 3 pieces of a triangle, now find the other parts. That's why a good way to start a question is by first identifying what you have and what you need. What you have is the information already given by the question. What you need is the information that the question wants you to find. Take this question for example. We have a theta of 30, an opposite of 5, and we need to find the adjacent. Here's another question. We have a theta of 60, a hypotenuse of 18, and we need to find the opposite. Confused? Good! Practice identifying triangle parts more. Now we can actually get to solving the questions. After you figured out what you have and what you need, you can now consult the formulas. In this chapter, there are 4 main formulas worth memorizing. The 3 trigonomic ratios and Pythagoras' theorem. Let's start with Pythagoras' theorem. A squared plus b squared equals c squared. C is the hypotenuse because, again, it's the longest side. Makes sense, right? I'm sure you can figure out what a and b are. You use this formula when theta is nowhere to be found and you need to find a missing side. If you need to find theta itself, Pythagoras' shenanigans are not for you. Here's an example of a question that uses Pythagoras' theorem. As you can see, there's no theta, 2 sides of the triangle are given, and you need to find the third. First, know what you have and what you need. Identify the hypotenuse, remember, opposite of the box, slap it into the formula, put in the other 2 values, and solve it. I'm sure you already know this, but remember that shifting values from one side of an equation to another changes its sign. Positive becomes negative, divide becomes multiply, square becomes square root, and vice versa. I'm telling you this just in case. Anyway, yeah, that's how you use Pythagoras' theorem. Practice and you'll get used to it. Now on to the 3 trigonomic ratios, sine theta, cosine theta, and tangent theta. Each of them have their own unique formulas. I know. I want to leave college too. You can cope with these basic formulas by remembering the right angle triangle beatbox. So, ka, tua. Confused again? Great! Let's slow it down a little. Sine theta equals opposite over hypotenuse. So, cos theta equals adjacent over hypotenuse. Ka. Tan theta equals opposite over adjacent. Toa. Do you get it now? No? Let's practice a little then. Here's a question first. Know what you have and what you need. In this question, we are given a hypotenuse of 5 and opposite of 3 and are tasked to find theta. Now that you know what you have, consult the formulas. We need to find theta, so Pythagoras will have to sit this one out. We have an opposite and a hypotenuse. So involves both opposite and hypotenuse. So we'll be using that. Sine theta equals opposite over hypotenuse. Sine theta equals 3 over 5. And now we can just solve it from there. Shifting sin, cos, and tan causes it to become shift, sin, cos, and tan. Rather silly, innit? On a calculator, you can get the shifted forms of these 3 by pressing shift and then the button for the one you want. Here's shift sin for an example. One last thing tied to this chapter is the angle of depression and elevation. It's very simple. Imagine a line parallel of your eyes, kind of like you're shooting a laser from them. Where this line is when your head is not moving is the ground. When you tilt your eyes up to look up, this line tilts up at an angle and creates a new line when you stop. The angle between this new line and the old line is the angle of elevation. On the flip side, if you do the same thing but look down, this is the angle of depression. That's it. That's all the basic information you need. Obviously, watching a dumb video made by a dumber man isn't going to make you a trigonometry master. To achieve that, you actually need to practice a lot. Like any math topic, really. Thanks for watching this silly video, and I hope you got something out of it. Thank you. Wait, I already said thank you. Oh, whoops.